Thank you for joining. Thank you for joining the broadcast. Remember to share the link with a friend. Remember to share this with a friend as we're going to start the lesson together. Welcome, welcome. We are doing a area approximation, and we are going to use the two main methods, which are the mid-ordinate rule and the trapezoidal rule. The trapezoidal rule. That is what we're going to apply right away. So I believe you're going to cooperate. Remember to share. Remember to share the link with friends. Just click the share button and forward this link to several friends as we begin together. Yes. So we are handling area approximation. So we are told that find the area enclosed by the curve y is equivalent to x squared minus 2x plus 5, with the x-axis between x equals to 0 and x equals to 5, using part 1, the trapezium rule, using 6 trapezia. Using a 6 trapezia. This is very key. Using 6 trapezia. So what we're going to do first is coming up with tables of values of x and y within the given range from x equals to 2 up to x equals to 5. Then we get the values of y. We can have the table drawn. Then from there we go to the formula and the application of the formula. X and y. So we have the first 2, 3, 4, 5, 6, and 7. So we're going to have from 2. So from 2, remember we want the trapezia to be 6. But between 2 and 5, we have only 3 intervals if we use a complete unit. Therefore, instead of using a complete unit, which will give us 3 trapezia, then now I prefer using intervals of half, which will give me the 6 trapezia, which is required. Therefore, I'm going to have 2, 2.5, then 3.0, 3.5, 4.0, 4.5, then I'll go to 5.0. So that is how I'm going to have my values of x. Remember, my purpose is to get 6 trapezia. And 6 trapezia, it should be noted that 6 trapezia are bounded by 7 strips. Therefore, I should have that communicated clearly, that 6 trapezia will be bounded by 7 strips. The strips will be the values of y. Therefore, the first value of y is when I substitute 2 in the place of x. So y is given by x squared. So I'll have 2 squared minus 2 into 2 plus 5. This gives me exactly 5. The next is 2.5. So I'll have 2.5 squared, then minus 2 into 2.5, then plus 5. This gives me 6.25. 6.25. The next is a 3. 3 squared minus 2 into 3, then plus 5. This gives me exactly 8. Then 3.5, whereby I'll start with 3.5 squared minus 2 into 3.5. Then I add 5. This gives me 10.25. 10.25. The next is going to be a 4. Therefore, I'll begin with 4 squared minus 2 into 4. Remember, I'm just substituting the values of x. I'm substituting the values of x in this function to get the corresponding values of y. The next is going to be, this is a 4.5. So 4.5, I square it, minus 2 into 4.5. Then I add 5. This is going to give me 16.25. 16.25. Finally, I got 5, so I square it, minus 2 into 5, and I add 5. This gives me exactly 20.0. 20.0. I had said, and I'm repeating again, that when we are using a trapezoidal rule, if you are given the number of trapezia to be used, then we should know that if it is 6 trapezia, they will be bounded by 7 strips. Therefore, the 7 strips can be named. If this one is named y0, this will be y1, y2, y3, y4, y5, y6. So these are the values I'm going to use. Therefore, I'm going to use the formula for trapezoidal rule, which is given by f h. Then I open the curly brackets, y0 plus yn. This is the general formula. Then plus 2 multiplied by the other values of y now, y1 plus y2. And I continue until the value of y just before the last one. Then I close my brackets. Therefore, f is a constant multiplied by h. H is the intervals from one value of y to the next. The intervals, or rather the heights of this trapezia. So from one height or from one length of a trapezia to the next, we are having a uniform height. In this case, we have it as 0.5, the intervals of x in this case. Therefore, we can say that h is the intervals of x. The intervals of x. Then y are the values of y. And now we can go into substitution because we are saying y0 is the first value of y. Yn is the last value. Then 2 multiplied by y1 is the second y here. Then yn minus 1 is the value of y just before the last one. So let me get into substitution in this formula. I'll begin with f. Then I got 0.5 as the intervals. Then I'll begin with the first one is 5. The last one is 20. Then plus 2 into. Now I substitute the other values. 6.25 plus 8 plus 10.25 plus 13. Then I add 16.25. I add 16.25. 16.25. So now I can compute these values now. 0.25 by half gives us 0.25. Then I open brackets. I'm going to have 25 plus 6.25 plus 8 plus 10.25 plus 13 plus 16.25. This is giving me, okay, 6.25, 8, sorry, 10.25, 13, then 16.25. This gives me 53.75. I multiply this by 2. So this is going to be 107.5. Then now I can get the answer. I'll add this to 25. then I multiply by 0.25. This gives me 33.125. 33.125 square units. 33.25125 square units. Now the next is use of the mid-ordinate rule using three mid-ordinates. So which means now for the six trapezia, I'm just going to get the middle ones. Just the middle ones. So for the six trapezia, I'll need the middle ones. Like for the first and the third, I'll identify this. Then for this, which is third and the fifth, I pick this one. Then for this and this, I'll pick this one. So that is what we call the mid-ordinates. We wanted three of them. And for six trapezia, we have three mid-ordinates. Therefore, I'll pick for 5 and 8 the mid, which is 6.25. The value is here. Then for 8 and 13, the mid, which is 10.25. Then for 13 and 20, the mid, which is 16.25. Then now I apply them in the formula, whereby I will say area is given by height into y0 plus y1. I continue adding up to yn. This is the last value of the mid-ordinates. In other words, the y's are the mid-ordinates. The y's are the mid-ordinates. Therefore, the interval between the ordinates, the uniform intervals between the ordinates. This is from 2.5 up to 3.5. This is from 3.5 up to 4.5. It means the intervals are of 1 unit. Therefore, I'll begin with 1. Then I multiply it with the first y, and that is 6.25. 6.25, that is the first mid-ordinate, plus 10.25 plus 16.25. 16.25. Therefore, I'm going to have 6.25. I add 10.25 and I add 16.25. This is going to give me exactly 32.75. 32.75 square units. And this is the value of the area when I use what we are calling the mid-ordinate rule. Remember, I'm going to give a second example so that people might understand well. I'll give the second example. But after that, we are told to find the percentage error in using the mid-ordinate rule as compared to the trapezium rule. Therefore, we're going to take the trapezium rule as more accurate. Remember, they are all methods of approximation. Trapezium, going to take it as our point of reference. Then we check our mid-ordinate as deviated from the trapezoidal rule. Therefore, I'm going to get 33.125, which is the area by trapezoidal rule, minus 32.75, which is area by mid-ordinate, and I subtract them. This is going to give us 0.375 square units. Therefore, the error, the percentage error, will be given by the error between the two areas, divided by the trapezoidal rule's value, because we are comparing it with trapezoidal rule. So I divide by 33.125 then we make it a percentage. So when I divide by 33.125 and I multiply by 100, I'm getting 1.132 to 4 significant figures percent. So this is the percentage error in the computation of the area. Allow me go to a second working, whereby I'm going to get area by again the two methods, and I'm going to be finishing. Remember, you can ask questions, you can consult, you can ask for revision materials through 0704 153 366. So that is my phone number. Complete the table below for the function y equals to x squared minus 3x minus 4. So we are completing a function here. We can start by doing that. When I substitute the value of x as -2 in this function, I will begin by -2 squared, then minus 3 into -2, then I subtract 4. This is going to give me exactly 6. The next is going to be -1.5. Therefore, I will start with -1.5 squared minus 3 into -1.5, then I subtract 4. This is giving me 2.75. 2.75. The next is going to be -1. So I'll start with -1, I square it, minus 3 into -1, then I subtract 4. This is going to give me exactly 0. The next will be -0.5. So I'll begin with -0.5, I square it, minus 3 into -0.5, then I subtract 4. This is giving me -2.25. The next is a 0. This will give us -4. When we substitute 0 here and here, we'll get -4. Then we go to 0.5. So 0.5, I square it, minus 3 into 0.5, then I subtract 4. This will give me -5.25. -5.25. Then when it is 1, I'll square 1, I subtract 3 into 1, and I subtract 4. This will give us -6. Then we have 1.5. So we'll have 1.5 squared minus 3 into 1.5. I subtract 4. This gives me -6.25. Yeah, 6.25. Then we have 2. 2 squared minus 3 into 2 minus 4. This is a -6. Then we have 2.5 squared minus 3 into 2.5 minus 4, giving us -5.25. Then we have finally a 3 squared minus 3 into 3, then minus 4. This gives us a -4. A -4. So we have the table filled. We have the table filled. Now we can proceed into responding to a few questions. Use the table and the trapezoidal rule with 11 ordinates. With 11 ordinates to estimate the area bounded by the curve x equals to -2 and x equals to 3 and x-axis for 2 marks. We use this table and the trapezoidal rule. Therefore, we need 11 ordinates. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are already 11 ordinates. And for the trapezoidal rule, which says that area is equivalent to half h into y naught plus yn, then plus 2 into y1 plus y2 continuously up to the y just before the last one. Then now we can substitute. I'll begin with the half. H is the height between, or the interval between, the values of x which are giving us the desired ordinates, and the differences I can see is just 0.5, 0.5, 0.5. So this is 0.5, the uniform interval. Now I open curly brackets and I will start with the first one, 6, plus the last one, which is a negative 4. It is good to note that when you have negatives as the values of y, you use the absolute values. So I'll use 4. Absolute value in the sense that negative is just showing that this area is below the x-axis on the negative scale of x, but we want the size. So the height of this trapezia is 4, only that it is on the lower side. So we use, instead of negative 4, we use it as 4. Then now we add all the others, which is 2.75 plus 0 plus 2.25 plus 4 plus 5.25 plus, after 5 and 25 we have 6, plus 6.25 plus 6 plus 5.25 just before the last one. Remember, I'm using absolute values and not exact values. I'm using absolute values of y. So this is 0.25. This is a 10. Then I add, let me add all these values, 2.75 plus 2.25 plus 4 plus 5.25 plus 6 plus 6.25 plus 5.25. Then I multiply this by 2. This is giving me 63.5. Then this is going to be, when I add 10, then I multiply by 0.25. This will give me 18.375 square units. Square units. So this is area by the trapezoidal rule. The next is telling us to find. Use the mid-ordinate rule with 5 strips. With 5 strips to estimate the area bounded by the curve. By the curve y equals to x squared minus 3x minus 4, x equals to -2, and x equals to, yes. So we are going to use the mid-ordinate rule in part B, and what we're going to do is we're going to get the middles of the 11 ordinates which we are having here. If we are having 6 and 0, the middle value is 1. If we are having 0 and -4, we apply this one. If we are having -4 and -6, we pick this one. If we are having -6 and -6 here, we pick the one at the center. Then if we have -6 and -4, we pick the one at the middle here. This is 1, 2, 3, 4, 5. So those are 5 ordinates. And we are going to use them in our formula. So in part B, area will be given by h into y0 plus y1 plus y2 plus the y plus the last one, all of them, yn. So we will have the intervals as the height, intervals between these mid-ordinates now. So from the mid-ordinate here to this one, we have negative 1.5 and negative 0.5. You can see the value is 1 there. Then here from 0.5 negative to 0.5 positive, the value is 1. From 0.5 to 1.5, the value is 1. Therefore, there is a uniform height of 1. It's what we are using here. Then we are having y0, which is the first value there, 2.75. The next is 2.25. Remember, I'm picking the absolute value even if a value of y is negative, since we just want area, and the negative sign simply means area is on the lower side of the x-axis. To 5, then 5.25. So these are the values I'm going to add up to give me area. Therefore, I'm going to have 0.75. I add 2.25. I add 5.25. I add 6.25. Then I add 5.25. This is giving exactly 21.75 square units. 21.75 square units. Then finally, we are told to calculate the exact area above the exact area. Therefore, for me to get exact area, I'm going to begin by doing a sketch. Let me do a sketch of this area so that I may use integration properly. I want to see how the area is behaving. Just before I calculate it. So we're going to have the area plotted. Now I'll use few values to come up with a sketch. Remember, you don't even have to write a lot of things, but I can have 1, 2, then 1, 2, 3 on the positive side. Then now I begin with negative 2 and positive 6. Then we will have negative 1 and 0. Negative 1 and 0. Then I can have 0 and negative 4. 0 and negative 4. Then I can have positive 1 and negative 6. Positive 1 and negative 6. I can have 2 and negative 6. 2 and negative 6. Then I can have 3 with negative 4. 3 with negative 4. Therefore, this is how the area is behaving now. From this point, I can see the area curving that way. This means I will have area which is below the x-axis and some other area between negative 2 and negative 1, which is above the area. So this means I will carry out integration twice. I'll start by integrating this curve from negative 2 up to negative 1 with respect to x. Then I integrate the same curve from negative 1 now up to positive 3 with respect to x because of the nature of this curve. So that is how I'm going to carry it out right now. The curve is y equals to x squared minus 3x minus 4. So let me carry out the first integration, or simply the integration of this curve. The integration is going to be of x squared minus 3x minus 4 with respect to x. This is going to give us, we will have the power increasing to 3, then we divide by 3, so it will be x cubed out of 3 minus the power increases to, it is already power 1, so it increases to power 2, and we divide here, so 3 out of 2x squared minus, we will have x, which is to power 0, increasing to power 1. So 4x. Then we add a constant of integration. So we can begin the first integration. We substitute between -2 and -1. Between -2 and -1. Therefore, I will substitute -1 first. So -1 cubed out of 3 minus 3 out of 2 into -1 squared minus 4 into -1 plus c. Then I will subtract, after carrying out that integration, I will subtract now x with -2. So I begin with -2 out of 3, but this is squared, minus 3 out of 2, -2, which is this is power 3, sorry. Then this is going to be squared, then minus 4, and I have -2. Then now I add the constant of integration, and I can now get these values. So I'm going to have -1 cubed divided by 7, divided by 3, sorry. Then I add, or I subtract, sorry, 3 out of 2 into -1 squared. Then I subtract 4 into -1. Yes, this gives me 2 points. Okay, can have 2 and 1 out of 6. I subtract. On this side, I'm going to have -2 cubed, then divide by 3. Then I subtract 3 out of 2 into -2 squared. Then I subtract 4 into -2. Yes, this is going to give me -0.6666, which is -2 out of 3. In other words, -2 out of 3. Therefore, when I take 2 and a sixth, and I also add 2 out of 3, I'm going to get a total of 2 and 5 out of 6 square units. That is the first area. The second area is the same integration, this one, but now I substitute between -1 and +3. -1 and +3. Therefore, in this function, I substitute -3. I'll begin with +3. So 3 cubed out of 3 minus 3 out of 2 into 3 squared minus 4, 3. Then after this, I'll subtract now -1, which has already been calculated here. This is 2 and 1 out of 6. So for -1, it's already calculated. Therefore, now I'm going to compute this one. 3 power 3 divided by 3. 3 power 3 divided by 3 to be 9. Then I subtract 3 out of 2 into 3 squared minus 4 into 3. So this is going to give me -16 and 1 out of 2. Then remember here, I'm subtracting 2 and 1 out of 6. So this is going to give me, when I subtract further, 2 and 1 over 6, I'm going to get -18 and 2 out of 3. This is square units. Square units. Now, this -18 and 2/3 square units, it means this is just area but on the lower side of x-axis. So that is why the area, is negative. So the absolute area, which is below the x-axis now, according to this sketch, is going to be 18 and 2 out of 3 square units. So now we can get total area. Which is equal to, we had the first area as 2 and 5 out of 6. Then we add 18 and 2 out of 3. This is going to give us the exact area. So when I add 2 and 5 out of 6, this is going to give us 21 and a half. 21 and a half square units. 21 and a half square units. So the area by integration is 21 and a half square units. Remember, if we integrated blindly from -2 all the way to +3, this function with respect to x, we could not have gotten the correct answer. Therefore, it's good to have a curve sketched. You see how the curve is behaving. Then now from that you can conclude that we have two different areas, area above, area below. Then you carry out the integration twice. You integrate between -2 and -1. Then the answer you get, you preserve it. You carry out again an integration between -1 and +3. Then now a combination of those areas will give you the total area. Remember that the area below the curve will be negative, and the negative answer now is simply meaning that the area is below the curve, below the x-axis. So when it is a negative value, now we have to take the absolute value, because we just want the amount of area now, regardless of where it is. We omit the negative and we have the area as 18 2/3 square units. Now this is the exact area by integration. We can look at the final answer, the final question, sorry, which is telling us, but roughly now we can see this is the exact area by integration. This is area using the mid-ordinate. This is the area using the trapezoidal rule. But now the last question is telling us to find the percentage error involved using the mid-ordinate. Because the value using the mid-ordinate is this, and the exact value is 21 and a half. Now we can get error, the error involved, part C, the error involved when using mid-ordinate. The error involved is going to be, the error itself is 21.75. We subtract 21 and a half. So 21.75 minus 21 and a half, it gives us a quarter, or 0.25. 0.25. So now the error 0.25 divided by exact area 21 and a half times 100. This is going to give us the percentage error. So I'll divide this with 21.5. Then I multiply by 100. So the error is 1.163%. So the error in the computation of the area using the mid-ordinate rule is 1.163% to 4 significant figures. Thank you for following. Subscribe and share. Thank you.